Hello, respected judge of SH 2024. Let's begin. This is the landing page of our application. First, the user will arrive at our landing page and click on Explore. Next, the user will either sign in using their email and password, or if they don't already have an account, they can create a new one using their email ID and phone number. OTP verification will be done via both email ID and phone number to ensure security. After login, the most important page of our application will appear. In the dashboard, the user will have multiple options such as enhancement of image, landing site selection, zone, boulders and craters, footprints, cloud data, and logout tab. When the user click on Enhance option, the interface will appear, prompting them to upload an image. By clicking Upload Image, the user can select a low light image of PSR permanently shadow region that they want to enhance. After uploading, clicking Enhance will first show the normalized image, which is the result of initial processing to enhance the low light image. We can also able to zoom it by clicking on the image, and we can get back again on the normal size of the normalized image. After that, when the user click next button, the noise normalized image will be displayed. In this stage, noise is reduced to improve the signal to noise ratio, which is SNR, making the image clearer for analysis. By clicking next, the equalized image will appear. To enhance the image further, the user can click Enhance to generate histogram equalizer image. After that, the next step will show a diagnosed histogram equalizer image achieved using advanced deep learning technique like CNN, convolutional neural network, and GAN, generative adversarial neural network. Finally, the user will receive the adaptive histogram equalizer image using the deep learning technique. This is the advanced process involve noise reduction and edge detection methods like Canny and Sobel filters. GANs, generative adversarial network, are also used to generate synthetic image for high quality enhancement, especially for the low light inputs. At every stage, the option to save image is available. A single click on an image will make it more clearly visible by zooming in. When the user click on the landing site option in the dashboard, it will show an option to upload an image. The user can upload the image and click on the result button. First, it will display a digital terrain model DTM image where the color scale corresponds to different altitude values. By clicking next button, it will show more complex terrain DTM image. Next, it will show the DTM of the landing site. Moving forward with next button, it will show the DTM of landing site. Moving forward with the next button, the image of the landing site with the 10 scientific stop will be shown. Finally, rover path with scientific stop and hindrance mark in a graphical representation. As this is our unique feature, from the landing site, a minimum 100-meter distance traverse the path with 10 scientific stops. For this, we have used Digester algorithm for finding the best 10 scientific stop. As you can see here, while zooming the node matrix, it has visited all the node and traversed back, due to which this red line occur, which show the best and optimal path. As generative adversarial network GANs, which use for generating synthetic image, which will generate annotated map of a lunar moon with the help of deep learning, that is GANs, and artificial intelligence, that is Digester algorithm. It become more beneficial to do the study of a topographical and geographical region of a lunar part of a moon. Next, in the zone option on the dashboard, the user can select the South Pole, equirectangular, or North Pole. For example, clicking on South Pole option will display an image of South Pole. Here the user can click on Show Graticule and it will display the South Pole region with guidelines marked with latitude and longitude coordinates, highlighting specific angle in degree. The user can save this image. The same applies when the user click the equirectangular option and then show graticules. It will display a section of moon surface map with a grid system featuring latitude and longitude coordinates. Similarly, for the North Pole, when the user explore and click on Show Graticule, it will display the grid system with latitude and longitude coordinates for the North Pole. Moving forward with the dashboard option, there's an option for boulders and craters, with two sub options available for the South Pole and the North Pole. By clicking on the option, for instance the South Pole, and then selecting the Show Craters, it will display an image of the craters on the South Pole with the name of the craters mentioned. Similarly, for the North Pole, it will display the image of the craters with their names. Now, in the dashboard, there is an option for footprints. When the user can upload an image. Upon uploading an image, there will be a two option: raw product and calibrated product of an lunar PSR region. When the user click on raw product, the raw image will appear, which is useful for scientific studies. Raw data is unprocessed data. The second option will be a calibrated product, which is also known as calibrated data, which will display an processed image when selected. Calibrated data is an processed data Finally, there is an option for cloud data where all the image history will be available. This is a complete overview of our application Chakor.